Anybody? Good morning, everyone. Welcome back. I think I've got everything graded that was turned in. And I'm trying something new here with the where our food comes from lab. Um, so let me know how it turns out for you guys. It was supposed to be like a peer review, just so you guys can really just see everyone else's work. Um, Hopefully it doesn't show your grade or anything, but let me know if that works or doesn't work. Does anybody see that? Did anything come up for you guys?
Yeah, it did come up. You go in and look at it. I see to do and a bunch of peer reviews.
Okay, so you don't have to really do anything for that. I really just wanted to use it as a way for you guys to see whatever everyone else's results were, just so you can see, especially some of the comments. And at another point, hopefully we'll open that up kind of for just some discussion. I think a lot of people had some interesting points from and learned some interesting things from that lab. It was hard for some people to get all the answers, and that's part of it. That's part of the design of the experiment, right? That we don't always know where our food comes from, and it's not always easy to find out. In fact, in some cases, it's kind of frightening how it's not easy to find out where your food comes from. In some cases, it's coming from another part of the world where they might not have the same standards as we have. So I think there are a lot of issues associated with that, but we'll talk about that more on another day. So you don't actually have to do anything on that. Just look through other people's. I don't think you actually have to have a submission. If it says anything like it's graded or something like that, let me know and I'll see what I need to do to change that. But I'm just experimenting with using these different tools in Canvas. All right, so I've got the first quiz was graded from the syllabus in that VDAX brochure, and I'm sure everybody's kind of gets a little upset at the fact that I always throw in at least one tricky question. I think I almost got everybody on that one. A couple of you did get it right. So the quote from George Washington, our second president, is one of those things where it's just a stupid curveball that I threw you. And the whole point of that is just to try to get you to read the whole question thoroughly and completely. So the quote was not false, but the fact that George Washington was our first president, not our second president, made the whole thing false, right? So just pay close attention to that. And I think what I'm trying to get across to you all there is that it's very important to pay attention to the details in the world of agriculture and really just this game of life that we all play. I accidentally did not publish the second quiz until this morning. So it's up now, and I changed the due date to reflect that. That's this Sunday, 11:59 p.m. So get on there and take that. All of the quizzes are open book, open note. I think that if you can find where the answers are. Sometimes I'll make it cryptic and try to hide them, but the answers are there somewhere. And some of them, are subjective. Like a lot of times the essay questions are really somewhat open for interpretation. As long as you answer it and follow the directions of answering that, like write a certain number of sentences to answer that question, or provide some evidence to back up your claims, then you'll get credit for it. But I'll often come back and put in some comments there or try to ask some questions about that just to kind of keep you guys engaged. So feel free to go back in and respond to my comments or just keep in touch in general. All right, so we'll move on into the world of ecology. And again, it's kind of a lot of slides to get through in one class period. So I might go through it a little fast, but you do have a slide sheet there on the Canvas page. If you want to go over that, and also the PowerPoint itself is posted up there too. So feel free to use that when it comes to quiz time. All right, let's get this up. All right, I'm gonna have to ask you to provide me access to share screen there, Tom.
I'm sorry about that.
That's okay. I wish there was a way just to turn it on where you didn't have to do that, but the downside of Zoom. All righty, here we go.
Okay, you should have it now.
All right, does that show what I'm hoping to show? You guys see the PowerPoint slide here?
Now we got it.
Okay. Let's see if it's gonna let me go through it here. All right, so if you're following along in the book, chapter 2, terrestrial ecosystems and their relationship to cultivating plants. Basically, we're looking at our part in it. All the terrestrial ecosystems are dependent on the producers, the plants, and their ability to act like solar panels and capture energy from the sun, and that miracle of life to where they can actually turn that energy from the sun into sugar. More details on that later. Of course, the climate determines the kinds of plants that grow naturally in the area, as well as the kind of plants that we can grow in an area, as well as the rate at which they grow. And usually the big thing we're looking at climate is temperature and moisture. It's also important to note that natural ecosystems are usually more complex than our crop ecosystems, but not necessarily always. I think you could create a crop ecosystem, an agro ecosystem that is as complex as a natural ecosystem, potentially. So let's kind of define the ecosystem here, which is simply the community of organisms in an environment interacting with the non-living factors, all the physical parts of the environment itself. And kind of the way that we define that environment determines the boundaries of the population. I think one of the important things to note is that most of these ecological processes we don't really see happening, but that doesn't mean that they're not there. And even in a greenhouse or even in your home, these ecosystem services, these ecological processes still exist. So it's different, right? A whole different set of environmental factors when you bring plants inside or grow them in a controlled environment. But we still have pest species. We still have soil organisms. Ecology doesn't disappear. There's always some interaction of multiple types of organisms going on. And that's important to look at the big stuff as the little stuff. They're all important to the ecosystem, the microorganisms as well as the macroorganisms. So we call where we produce a crop an agro-ecosystem, which stands for agricultural ecosystem. So we've changed a lot of the kind of parameters, the variables in the agro-ecosystem from a natural ecosystem. You know, we went in and cleared land to start the farm, and in that we heavily modified those factors, but they're still there. We still have the same processes taking place. So it's important to think of whatever kind of production you're looking at as an ecosystem. So looking at some of just the components of an ecosystem, first we think of are the basic needs of any organism. And so right now I'm just thinking of plants. Plants need light, water, nutrients to grow. And if you have more than one plant competing for the same limiting resource, then one of them is going to try to outcompete the other. So think of it like weeds, right? You have weeds competing for light or water or nutrients. And when they draw on that same limiting resource, we have competition. And we think about these resources. It's important to note that not all those resources go to one thing. All the resources are shared amongst everything in the ecosystem. And from that, we get different niches. So a niche is just the role and the position that any species has in that ecosystem. It's like its job and its habitat, both in one. And to coexist, different species have to either compete for different resources or be kind of in a different space in that ecosystem. In a healthy natural ecosystem, almost every single niche is filled and almost all of the resources are fully exploited. Nature abhors a vacuum, right? So if there's bare soil, then a weed will grow there, or another plant will. It doesn't have to be a weed, right? So we think of it kind of as a closed loop. And in our agricultural ecosystems, we kind of want to try to apply that as well. Because of a healthy natural ecosystem having all of these resources exploited and all of these niches filled, it is difficult for new species to enter that environment. Whenever we disturb the environment, we open it up for new species to come in. So this results in this whole ecological paradigm of competitive exclusion, which basically says that no two organisms can occupy the same niche competing over the same limiting resource. They either have to have a different niche or a different resource in order to not compete. One will always outcompete the other. And that's competitive exclusion. So in the agroecosystems, we tend to have one or maybe a few species that do not exploit all of that environment. And so in the case of bare soil, let's say that we've plowed and tilled and prepared this soil, and we put our plants in, but there's space available in between. A weed will come in. So that's one of the big issues that we grapple with in field production of plants. What do we do with the weeds, or in livestock production as well? So if we apply an ecological concept to this, we might look at a weed control strategy as planting some additional non-competitive crop plants to occupy those niches that would otherwise be occupied by the weeds. So we might do things like cover cropping or undersowing. And we used to do this with our sweet corn. We would, in between the rows and under the plants, kind of undersow it with a white clover. That clover is basically it's occupying the niche that was that bare soil. And it's also providing a little bit of nitrogen to the corn crop too. So cover cropping and intercropping or undersowing are good kind of ecological weed control strategies. Some other things to look at here are the ideas of predation and parasitism. And one of the big issues we have with that is when predators, in this case, or parasites, are looking at our plants. That's kind of the niche that they're occupying. Their role is to eat that plant. So they are kind of using that as their prey in many ways. and consuming that. So in a lot of cases, we lose a lot of resources to these insects, slugs, snails, mammals, birds, whatever. Crop ecosystems are usually more vulnerable to this because the number of natural predators for those organisms is low or non-existent. We changed that ecosystem, altered it to remove the predators, or we introduced something new to the ecosystem that can eat our crops. And because of that, we have to fill that role of controlling that, that predator, that insect or mammal or whatever it is. Be the hunter, not the hunted. We also have the idea of parasitism, which is a little bit different in that it's this long-term relationship between the hosts and whatever it is that is using it as a resource. In the case of parasitism, it doesn't usually consume the whole thing. It just uses as much of that resource as it can while still keeping it alive. Let's look at some ecological relationships here. One, again, that we don't see but is very important is just in the growth of roots of our crop plants and interacting with a fungus in the soil, mycorrhiza. Mycorrhiza is kind of a mutual organism that is helping to provide nutrients to the plant, minerals and nutrients, and in exchange getting some sugars from the plant. And in a lot of cases, they're now offering mycorrhiza as an addition to crop soils, as an amendment. You can purchase it, put it in the soil, and a lot of the potting soil mixes, they have it in there so that they're actually getting better nutrition and reducing the need for fertilizers. We have all kinds of different relationships in ecology, and we call these relationships symbiosis, where the symbiote lives in some sort of direct relationship with whatever organism it is that we're looking at. So another form of that is rhizobium, and rhizobium is a soil bacteria that forms these nitrogen-fixing nodules on the roots of many species in the legume family. Like that clove I was talking about earlier, you can kind of see in this image here, we've got these nodules on the roots. That's where this bacteria lives. It's able to take nitrogen out of the air and put it into the plant. And this is a beneficial relationship for both organisms. The rhizobium's getting a home on the roots of the plant. It's getting some habitat, and the crop is getting some nitrogen. So that is mutualism, where both organisms benefit. We got commensalism, where one organism benefits, but the other is not harmed nor is benefited. And that would kind of be like the lichen found on a tree trunk or moss growing on it. It's getting some habitat, but it's not really providing any damage or benefit to that other organism. So both dip and parasitism, where of course in parasitism, one organism is harmed and the other benefits. So in all ecosystems, plants are our primary producers because they're taking energy from the sun and turning it into something more complex and transferring that energy up these trophic levels. And the trophic levels here are basically, they're color-coded in this case of moving up. So it's a way of moving energy from the producers up the food chain, or really the food web, because it is just a complex web of relationships of all these different organisms and how that energy is moving from one producer, the autotroph, up to the consumer and up to other consumers. So each time we move that energy up a level. It's a different trophic level, and yeah, just an important part of the ecosystem. Let's skip over here. This idea of biomes, where we have basically collections of ecosystems where you have a similar climate, soil, and plant composition. Not the same, but very similar. And the explorer Alexander von Humboldt kind of noted that he saw this progression of vegetation types as he moved away from the equator. And also, so we have a change in these biomes in latitude, but also in altitude. As you go up in elevation, it changes. And those changes in altitude often reflect what would be like a change in latitude. So for instance, if y'all ever get the chance to come over here to Southwest Virginia, we've got the highest peak in Virginia, Mount Rogers. And if you go up there, then they say it's like going several hundred miles north. It's more like an ecosystem that you would see in like Canada, just because you increased in elevation by several thousand feet. So we see this for a couple of reasons. Of course, with the change of latitude, we got the change of light, the photoperiod, but we also have a change due to air circulation. The westerlies and trade winds are helping to move bodies of moisture, basically, and that helps to change the biomes. So we get this giving rise to deserts, which are the largest biome on the planet. Areas where that moisture is carried away from these geographic areas. So that the plants that do live there have to be specialized to grow very slowly or only when rainfall is available. So like the Mojave Desert and Baja in California and the Southwest, very dry, very arid. Large part of Africa, Australia, parts of South America, parts of Asia, makes up the largest biome on the planet, desert land, which, while it doesn't have a lot of natural moisture, it does have the potential to be productive agricultural land, if you can add the water to it anyway. Between 40 and 50 degrees latitude, we've got mostly temperate deciduous forest. That's what we've got here in the mid-Atlantic. Between deserts and forests, we usually have grasslands and savannas where we don't have much tree growth due to there not being enough moisture for trees to grow, but enough moisture for there to be grassland. And this is some of the most important agricultural land that we have. We also have a zone or biome of kind of boreal forest called taiga. It's actually the second largest biome on the planet. And we have cooler temperatures there because of the increase in latitude, but also we have more precipitation, which leads to more forest land. And in this, we have a lot of coniferous trees. We mostly see the taiga in the northern hemisphere, and that's mostly just because nearly as much land in the southern hemisphere at that latitude. So in South America, there is some taiga there, but there's not nearly as much of it as we have in the northern hemisphere, mostly looking at Canada, Alaska, parts of Russia. And plant diversity is lower than we would have in temperate or tropical forests. And I think one of the important things to note on the biomes is that the kind of natural communities that we see sort of reflect how it might be used for agriculture. So In the taiga, there's not a whole lot of agriculture being practiced. We do have some pasture for hay, and we have some subsistence farming taking place, but there's not a whole lot of agriculture because it's cold. In some of those areas, though, if anybody's ever been to Alaska, you might know that they have a very short growing season, but it is intense because that period of time where we do have that growing season, they have a lot of daylight, sometimes 24 hours, going towards the summer solstice. And because of that, it's a really intense growing season. You've probably seen pictures of massive cabbages that come from those areas. North of the taiga, we've got the frozen, although see more and more news stories about it starting to thaw out a little bit. We got permafrost. We can't practice agriculture. Almost all the biomes on the planet have been influenced by us. Some have been close to being destroyed completely. The grasslands, the prairies of the Midwest have been extensively modified, plowed to become the breadbasket of the world. Temperate forests have been harvested for timber. A lot of that was converted to farmland. And then some of those areas have been abandoned from farmland due to poor soil management and are back to woodland now. We have done a lot of tropical forest clearing for agriculture, and those areas don't really recover very well. Another important ecosystem we've impacted are wetlands, which kind of act as these ecological buffer zones. And they refuge different plants and animals, very important to the ecology. And for the longest time, we drained a lot of these wetlands to become productive agricultural land. Actually, near here, we have a place called Shady Valley, just over the mountain, and it was known as one of the largest cranberry bogs in, I guess, south of Massachusetts. And they drained it. The Army Corps of Engineers came in and drained it for agricultural land. It's interesting because it's about 3,000 feet in elevation, so it makes for an interesting kind of a set of agriculture. A lot of spinach going on up there, a lot of apple growing. Nonetheless, wetlands are very important. I think it probably would have been neat just to have cranberries produced there, but whatever. You can't undo that. Once you drain the wetland, you really can't change that. So biomes that contain wet areas or wetlands were very productive agricultural land because that organic matter got stored and there was lots of available water. And then we drained it for crop production and left those natural areas more vulnerable to drought. So there's a couple of pockets there that have been preserved, some intact cranberry bogs, but most of it is gone now. All right, so along with that, we've kind of figured out that almost all the land that we can cultivate, all that arable land, we're using for the production of crops. That's not always true, of course, especially as agricultural patterns change and people no longer farm. They abandon the land and it goes back to starting to make forest again. So not all of it, but a lot of the land that could have been easily cultivated is being used for the production of some crop. And of course, we have that whole issue with world population rising. We got to produce more food. But how do we do that when we're not making any more land? All right, so looking at the productivity, of the terrestrial ecosystems. Plant productivity, or net primary productivity, is the amount of carbon dioxide taken from the atmosphere through photosynthesis. So really, we're looking at it as the amount of biomass produced. And through the guise of the amount of carbon being fixed from simple carbon dioxide into more complex compounds through photosynthesis. So it's looking at primary productivity of an ecosystem. It's not necessarily looking at the crop productivity itself. So if we look at the different ecosystems out there, we've got the highest are in tropical areas, that the most productive, tropical rainforests and tropical savanna, because we have lots of higher temperatures and lots of moisture. So these are the most productive, and that accounts for half of the world's productivity, but it only makes up less than 1/4 of the actual land area. Our temperate forests, kind of the natural ecosystem here, is almost as productive, but it only contributes to about 10% of global productivity because it only occupies about 7% of the land mass, and because it is composed of deciduous trees and we have cold winters, it is only photosynthetically active part of the year. We have boreal forests, temperate grassland, and cropland. They're fairly close to each other, and they take up a fair amount of land, but they are only about half as productive as temperate and tropical forests and savannas. So each of these is kind of contributing differently to the global productivity from these biomes, and kind of getting that kind of matched with their share of land. It kind of all works out eventually. But it's just important to note that the cropland is not as productive as natural ecosystems. And there are some scientists kind of working on just trying to change that. One of the organizations, the Land Institute in Kansas, is basically looking at how to develop more perennial crops. So they're looking at trying to make their grasslands kind of more like the natural prairie. And Wes Jackson, the guy who started Land Institute, is quoted as saying that he believes that we cannot do better than nature. I would argue that I think that we can. I think that they're actually kind of working towards that. We might not be able to do better than nature in terms of just the net primary productivity itself, the amount of biomass produced, but we can change that to be more of a harvestable portion of whatever crop it is. So I'll post up a link to the Land Institute so you can check it out. It's pretty fascinating, the work that they're doing, trying to breed these crops to be more perennials rather than annuals. All right, so 1/3 of the Earth's surface is occupied by these biomes that are not productive really whatsoever. Tundra, because it's so cold; desert, because there's not enough moisture; and also kind of just other arid areas. And then, of course, urban land. So urban areas have about the same productivity as tundra, but they only occupy about 1.5% of land surface. So not much productivity going on there, although I think we've seen with changes in technology, there's more crop production taking place in urban environments. Whether that's good or bad, that's to decide, but it's happening. So we think of carbon fixation, this kind of movement of carbon dioxide to carbon in the plant and eventually into the soil. Crop productivity is not the same as that net primary productivity of an ecosystem, because when we look at crop productivity, we're looking at a very specific part of the plant being harvested, whereas when we look at the net primary productivity, we're looking at all the biomass. So we look at the harvest index, and so our goal is try to get more of a harvestable portion of the crop in order to increase our crop productivity. thing to know about these ecological communities is that they are dynamic. They change over time. They don't just stay the same, right? So this change in the plant communities over time is called succession. And we look at that in changes in vegetation, changes that lead to, I think, more dynamic changes. As you have that change in vegetation, you have a change in available moisture, for instance. So let's just kind of think about both ends. Like a climax community is one that has reached that final stage of succession, and it changes very little. It doesn't mean it doesn't change at all, but it doesn't change quite as much as, say, a recently cleared area, something that's younger in succession. So we think of a climax community as like an old growth forest. Lightning's going to strike and trees are going to fall. Trees are going to get old and just fall over. That opens up areas, and there's still change happening, but overall they don't change nearly as much. If we think about clearing land, forest land, if we didn't practice agriculture on it, then it's going to have pioneer plants coming in. Usually these are things like brambles, blackberries, stuff like that. They grow and they protect trees that are growing, things like eastern red cedar. They start growing and then they shelter other trees. Trees then outgrow those cedars, things like pines, stuff like that, growing faster, sheltering other plants, and eventually it returns to whatever forest type it would have been naturally. And for pretty much the entire eastern US, other than wetland areas, that climax community is a forest type. So if we clear it and we leave it alone, then it's going to go back to forest. However, we have to think about how we have changed it. We are a keystone species interacting with the ecosystems. And unfortunately now when you clear land, if you abandon that land, then what grows back is often invasive plant species, non-native plants that were brought over often from Asia. They grow and make it weedy and not as productive. The net primary productivity might be high, but it's not productive in terms of for the natural kind of native organisms, if that makes sense. So again, in a climax community, most of the niches are filled by what had the survival of the fittest, what the fittest organism was. So we have this long history of moving different plants and organisms around intentionally or unintentionally. And because of that, we've irreversibly altered a lot of the ecosystems through these introduced species. And one example of that is the American chestnut. We decided to import different types of chestnuts, Chinese chestnuts, Japanese chestnuts from Asia. And with those imported chestnuts came the chestnut blight, and it decimated the American chestnut. Probably wouldn't have killed all of them, but the timber industry, the chestnut was very important because it was the tallest tree in Eastern North America, and it was very well preserved wood too. So they said, all right, if we're losing all the chestnut trees, let's go ahead and get as much timber out of it as we can. Probably in doing that, they probably cut down some resistant varieties of the American chestnut. So anyway, we completely altered eastern forests. They say that the American chestnut made up about 2/3 of the canopy in Eastern North America. They had really sweet nuts, and deer, all kinds of different, turkeys, all kinds of different organisms depended on those chestnuts for a food source. And they say that the flavor of the meat has changed because they went from eating chestnuts to now eating what took the place of the chestnuts, which is oaks and hickories. They started eating oaks and hickories. Oaks are more bitter. They have more tannins in them. And the change resulted in a change of flavor of the meat itself. So who would have thought that by importing a plant, we ended up changing the way that hunters enjoy the flavor of a wild game. That's just one example. There's all kinds of examples out there where we have introduced an organism either intentionally or unintentionally that has taken over and completely changed ecosystems. The eastern hemlock is another good example where we accidentally introduced this adelgid, this insect from Asia that is destroying these eastern hemlocks. As they die, they were once shading streams, and a lot of fishermen are seeing that these streams become warmer. They can no longer support trout species. So it's not only just affecting the ecosystem, it's also affecting the recreational or even the kind of food that we get from these ecosystems. All right, so I think one of the things that we look at in ecology is, of course, that whole net primary productivity being driven by this sequestering of carbon. And this idea of carbon offset credits, I think is something that farmers could get in on, and we're starting to see some actually engaging in it. But we have a unique position in the world of agriculture to where we can have a big effect on that sequestration of carbon. And therefore, we should be able to get these carbon offset credits, which then you sell to other places that are producing a lot of carbon emissions. That's kind of an idealized version of what the, I guess, carbon market, the climate market that has been kind of theorized and thrown out there would look like. And I just want to note that while I think it would take a lot to get this system implemented, I think there's a lot of potential for farmers in that. And it could be a way that farmers could get more money off of their land. We actually have a pretty good example of that working in the past. They created a kind of a cap and trade system on sulfur dioxide back in the late 80s, early 90s. And in that period of time where they did that cap and trade, they basically said if you produce sulfur dioxide, then you had to pay someone that, I guess, either sequestered it, or you had to pay someone that was mitigating that sulfur dioxide, which was causing acid rain and was eating a hole in the ozone layer, all kinds of kind of nightmare scenarios associated with that. But because of that cap and trade system, they were able to completely remove that issue of sulfur dioxide pollution and really mitigated the problem of acid rain. Fascinating thing about that, though, is that some of the farmers that were near power plants that were producing acid rain, or sulfur dioxide, I should say, that then turned into acid rain, were actually getting some sulfur in their soils from that, which is a necessary micronutrient for crops. And once that went away, they started having to go back and start fertilizing with sulfur again. Kind of a funny side effect of it. So the idea is that you purchase credits, companies would purchase and sell them as payments, a way of trading, and I think that we have the most potential impact on that in the agriculture world. All right, the last thing here, thinking about the impact of cultivating plants on ecosystems and the environment as a whole, is just that embedded energy, the energy that we have involved in the food supply and food production system. which just in the production is not that big of a deal. I think it's something like 2% of U.S. Energy supply is going into just the production of crops. But after it leaves the farm, the transportation, the processing, the storage, all of these are energy users. And as it is now, of course, we're transporting products across the nation, across the world in some cases, which causes them to have a higher carbon footprint. If the rest of the world kind of did this same type of agricultural production and then, I guess, provision, then it would use up about half of the world's energy supply. So lots of embedded energy in agriculture. All right, I know that was quick and a whole lot of information in a short amount of time, but we'll turn it back to you guys, see if anybody has any questions, comments, or concerns. Anybody? What do you all think? Carbon credits, good idea, bad idea? For the farmer, anybody? What do you think, Tom?
I think it's an interesting economic opportunity for the farmer, but I don't know how much it would actually promote the farmers to be doing more carbon positive stuff, because we kind of are doing what we can by planting our crops and that kind of thing.
Yeah.
So it's an interesting income source for the farmer, but I don't know that it would, it's just sort of giving license for companies to keep polluting. So I don't know that it would really have that big of an impact.
Yeah, it's an interesting concept. It doesn't really look like it's going to happen, though. There for a little while, they actually had a climate exchange market in Chicago, but it quickly kind of went away.
Yeah, which I do like the idea, the business form of it, to encourage some business out there that could get greener, they can get an economic reward for it. But like I say, for agriculture, we already are fairly green, so.
Yeah. We're already doing it. So can we get a little extra money for what we're already doing? Maybe.
Yes, that's the hope. There's a little economic love there, but don't know if it'll actually help the environment.
I think we had everybody complete the first quiz. So did anybody have any questions or comments on that first quiz? Concerns, gripes, or grievances? I just kind of wanted that one to sort of just be an example of this quiz and testing style. When it comes to exam time, it'll basically just be those questions recycled, except it won't be open book. We'll use the lockdown browser, which I guess I probably shouldn't say, but in many ways, that's still open internet. You got a mobile phone with you, you can still Google answers, right? I probably shouldn't have said that, huh? Are all the answers Googleable, though?
Depends on how you wrote the question.
Hopefully not. All right, well, I think that's it for me. Hope you all have a great rest of the day, and I guess we'll see you next week.
Yep. Have a good weekend.
Take care, everyone.